In this video, I'm going to be going through the 2018 preliminary HSC or Year 11 end of year exam. I'm going to be going through this pretty quickly, so let's have a look. Young's modulus is ability is the stiffness of the material, D. The property of steel rolling improves strength. Identify the most suitable forming process for aluminium window frames, extrusion. Which statement best describes the transformation of energy that takes place in brakes? Kinetic energy is lost producing heat. Yeah, that sounds good. Perlite is a mixture of cementite and ferrite. I paused there because I was remembering that I went through this with my brother when I did this last year, and he took a crack at it while we were having lunch at the Meridian, and he was able to figure that one out just by the way the question was phrased. It was interesting. I think he may have passed, and he didn't do any engineering. He's all of his uni was in biology. What is the material that forms when 0.6% carbon is heated to 900 degrees and then quenched in oil? That would be martensite is what's produced, and then we temper it by heating it back up. Which one has the highest coefficient of friction? I've talked about this at length in other videos. Steel has a pretty high coefficient of, that has a pretty low coefficient of friction, especially if it's lubricated. Rubber has a high coefficient of friction. This is like I felt defensive when I made this question, and it is in the textbook, so that was the basis that I went on. But I have talked about coefficients of friction in detail in videos. Okay, in this picture, I've talked about this, I think, recently, so I'm not going to harp on it. We're looking at the front view. It looks like a sandwich, so it's going to be this triangle. When we're looking from the direction of that arrow, we're going to see this line here in the top corner and this in the bottom corner, so it's going to be either A or B. And then if we're looking in the direction from where we're our front view, as we go further back into the page, we're going to have a line that is parallel to the viewing plane. Now, Copeland likes to refer to this as perpendicular to the axis of the view. I like to think of it in terms of being perpendicular to the piece of glass in front of the camera. That's how I like to think of it. So it's going to be A is the short answer. Which of the following is the second order lever? The second order lever is going to be where the load, or the load of number 2, is near the wheel, right?
1, 2, 3.
Yeah. Is this a good question? I don't know if I like these questions anymore. The only advantage is that recognizing a second order lever can kind of give you an idea that second order levers must have a mechanical advantage greater than 1. Third order levers must have a mechanical advantage less than 1. First order levers could go either way depending on the configuration. And that would be a better question if I said which of the following has a mechanical advantage greater than 1. Which statement best describes MIG welding? MIG welding is when a continuous metal electrode is shrouded by inert gas, D. What is the term for the difference in electrical potential? That'd be voltage. Or the electromotive force really gives it away. That's easy. That shouldn't be a question 11. That should have been higher. Which of the following best describes engineering management? D. I think I've gone through that one more recently. They're all important, but that one encompasses the other ones. Why are teeth hardened? Teeth on gears hardened so that they withstand wearing, to reduce wearing. A. Which statement best describes the process of normalizing steel? Heat to red hot, or heat to 100% austenite, but heat to red hot is fine. And then to normalize, we cool in air. So, heat to red hot, then cool in air. A looks good. I'm not going to overthink it because I'm trying to do this quickly. So it's possible that I don't want to get one of these wrong and be wrong on the internet. And that does sometimes happen when I don't read properly. What is the stress due to? So it's 300 newtons, 0.3 kilonewtons is 300 newtons, and then there's a diameter of 15 millimeters. So, well, first of all, diameter, you got to be really careful, right? You don't want to use areas instead of diameters. Really read that twice. My tendency is to think that everything is a diameter, and that's what gets me into trouble. So, pi r squared or pi d squared on 4. So we're going to go, the diameter is 15 squared times 15 times pi divided by 4 equals 176. Stress equals force over area. 300 divided by 176 equals 1.69. Because we use millimeters, we go together like megapascals and millimeters squared. The answer is C. So this, we're using the disco number to find the vertical component. So 0.866 times 4.16. Obviously, you can use trigonometry. I don't really feel as though I need to teach you trigonometry. That's assumed knowledge for the course. I have explained it many times in class. There's a YouTube video where I've recorded where I went through it this year. So at the time of recording. A box has a mass of 30 kilograms. What force is required to push it? Now, without any other information, we always assume it's a perpendicular force, so that the normal force is going to be equal to the weight of the box. So a thing that we have to consider is that we have to multiply the box by gravity. So we're going to use 300. Someone asked me recently, can you use 9.8? Yeah, you won't lose marks if you use 9.8. So we're going to say 300 times, so F equals mu n in this case equals 300, mu equals 0.6, 0.6 times 300 equals 180. Okay, which statement accurately describes what alloys strengthen metals? I do like these questions. Let's have a look. Foreign atoms tend to block a slit because they distort lattice bonds. Yeah, that'll do. Yep. More grain boundaries is why work hardening works. Yeah. Okay. What is the velocity ratio of the lever shown? Oh, I like this question. I like it. Okay, so the thing is, a lot of people don't measure to the fulcrum. This is quite a reasonable question. It's a third order lever. So a third order lever should have mechanical advantage less than 1. So that means it's going to be 600 divided by 1900. If you don't get why it's 1900, it's because you've got to measure all the way from the load to the fulcrum. So the answer is A. Okay, so this question, what we get when we do the area that's in parallel first, so we have 1 divided by 3 plus 1 divided by 6, or 1 over 6. I'm just going to do those fractions. I'm going to say 0.33 plus 0.166 equals 1/2. So I do 1 divided by that answer. It gives me 2, right? So it's going to be 2 plus 2 equals 4 ohms of resistance. So we got, good job. Okay, identify the health and safety consideration relating to the field of biomedical engineering. The one that people typically refer to is infection. There's a risk of infection when you're working with people who have communicable diseases. I always seem to focus on, probably excessively on radiation. Radiation is a very small aspect of radiotherapy, and radiodiagnostics is a fairly small area of biomedical innovation. If you're working with MRIs, the magnets are really quite dangerous and they need to be treated with a lot of respect. You could talk about biocompatibility, so making sure that when you put things in people's body that they're not going to break apart, they're not going to be something that your immune system will attack. I think that'll do. Describe one ethical consideration relating to biomedical. Okay, the best example is animal testing, but people do tend to focus on the cochlear implants and objections to those. Explain one social benefit of an innovation. Improved quality of life. People aren't in pain. So it's a social benefit of one biomedical innovation. Well, I would suggest hip replacements is what I asked you to do as your engineering report on. So you could say people aren't in pain, people have improved mobility, so they don't need as much expensive care. They can return to the workplace. That's 3 marks. Explain why drum brakes were replaced by replaced contracted band brakes. Because they're not as affected by debris. Because they're a sealed container, they don't allow for leaves and rocks and things to either get between the brake and the drum, and also they tend not to get in the way and cause mechanical failure. So that's the main reason. That's a bit of a long wordy answer, but I'm trying to do this quickly. Describe the function brake by wire. Great question. So brake by wire replaces physical cables. It allows an electrical signal to be sent from the brake pedal to servos and actuators, which cause the brakes to apply. These have an advantage. That's a describe. If the question was explained for an extra mark, what I would say is these have an advantage over traditional or mechanical or hydraulic braking systems, in that they are more reliable and they have better response times and they have reduced weight. Weight's not as much of a problem when it comes to the Year 11 course. When we talk about fly-by-wire, weight becomes a big issue. Define durability, bad question. I wouldn't use this now. So since I've had more exposure to talking to people, senior HSC or experienced HSC markers, they don't like the term durability. You should be talking about corrosion resistance, wear resistance, erosion resistance, chemical resistance, those sorts of things. Just strength. You could talk about service life. That's a bit nebulous. You could talk about UV resistance. But all of those things together, they create the term durability. The same way, we probably shouldn't just use the term strength. You should always define strength as being a certain kind of strength. So you should say like tensile strength, for instance. I'm going to zoom in. I probably should have start off zoomed in, but we are what we are. Okay, identify the name of the process of reheating quench steels to improve their toughness, tempering. Sketch a annealed 0.6% carbon steel. Well, what I would do is I draw a couple of lines, and I would draw a straight lines across 2/3 of them, because at 0.6 we're not at full perlite, and then you need to label it. You don't get marks. You only get 1 mark for the drawing. You get 1 mark for the labeling. Let's have a look.
I drew it more like squiggly lines.
Yeah, not squiggly lines, just straight lines. So parallel straight lines through half of them. If you look at my other videos, you'll be able to see good examples. Also, I have a YouTube video where... no. Okay. Describe the process of annealing 0.6% carbon steel. Heat to red hot, then cool in a furnace. That's a pretty quick answer. A better answer would be heat until you have 100% gamma steel, or heat until full austenite, then cool slowly in a furnace. Yep, that's what they're looking for. That's an easy 2 marks, I think. Okay, the picture below shows 3 components of a hip prosthesis: ball, stem, and cup. Use the diagram. You don't have to use acetabular cup. Use the diagram to explain why a forged stem is generally stronger than one that has been machined. You should have done that when you did your engineering report. The idea is that, the grain flows around the shape of the machined object of the forged object, the machined object, the lines are parallel. Forging is better because you don't have points of weakness. Those parallel lines are going to cause points of weakness here and here. Describe the process of investment lost wax casting. I really like these questions. So the 4 steps are, first of all, you make the thing out of wax. You then coat it in ceramic. You melt the wax and pour it out. You then fill the ceramic with metal. You then allow it to cool and remove the wax casing. Each of those steps is worth half a mark. There's no half marks in the HSC, but that's how we work. Identify 2 material properties that make aluminium desirable material for lawnmowers and explain their benefit. They're light, and so property is lightweight. You could say in year 12, if we're talking about, say, aviation, I really want you to write good strength to weight ratio. It's a much better answer than just writing lightweight, but I would definitely accept lightweight. The benefit is that it reduces the weight of the lawnmower for users. Makes it easier for them to lift it in and out of the garden shed. The second property is that they're corrosion resistant, which means that they have a longer service life. They're not going to need to be replaced as often. Copper wire is, they're the 2 go-to answers, right? That's pretty easy. 1 for the property, 1 for the benefit. Copper wire is 8 meters long, has a cross-sectional area, so note that they've given us area. Given that Young's modulus for copper is 111 gigapascals, calculate the extension of wire if it experiences a tensile force of 300 newtons. Okay, so this is an E equals Flee question. So when we write capital E equals capital F, capital L divided by little e, A. The thing is, in this case, you're allowed to swap the lowercase and capital E's. So what we get is capital FL divided by capital EA. So our force is 300 newtons. It's already in newtons. We can leave that. Times L. L is given in meters. Oh, that's a long wire. Okay, so we're going to type in 300 times 8,000 divided by brackets. Our E is 111 times 10 to the 3, or 3 zeros. The reason for that is gigapascals is 1,000 megapascals, and we go together like megapascals and millimeters squared, multiplied by 0.5, close brackets, gives me an answer of 4.32 millimeters. So we got?
No, I didn't do it.
Okay. E equals flea questions, easy questions, definitely the sort of thing likely to be in the HSC. You should be prepared for that. You could instead do stress over strain. That's what the formula sheet directs you to do. It's just you can do it in one step if you do it this way. Okay, we've got a digital circuit uses an AND, NAND, NOR logic gates as shown. I'm not very happy with the size of the dots. So the top one here is a NOR gate, down the bottom is a NAND gate, and then we have an AND gate. I mean, I've labelled them, so I think that based on the fact that they're labelled, I've described them in the question above, that does really help. Okay, so what are we looking at? In the truth table, if we have 0, 0, so it's a bit difficult to refer to this, but say if this is 0 and this is 0, well, an OR gate says either of you on the list, neither of you on the list, so that's a 0. But then the not dot says, never mind, you're in. Over here we have, so it's a 0. So here we have 0, 0. The AND gate says, are both of you on the list? And they say no, and then the not dot says, don't worry, you're in. So it's going to be 1, 1, and then an AND gate says, you're both on the list? And they say, yes, we are, 1 and 1, so Z is 1. Because of the way that these things are set up, I'm pretty sure all the others are 0, but let's go through it. If 1 is 0 and 1 is not, the OR gate says, so the OR gate says you're on the list, and it says, well, one of us is, and it says, yeah, okay, and then the not dot says, nah, don't, and so that means it's a 0. And so if you have a 0 here, in either of those configurations, we're going to get a 0 here, which means that all of our other configurations are going to be 0. I'm pretty confident of that. I'm too lazy to look it up. So there we go. If I'm wrong, by all means, let me know. Okay, so in this case here, we've got 2 cylinders. These questions are really common. We can see that this one is bigger. So remember, big force, big area, big force. So what we have here is this one is 60, this one's 35. So the diameter ratios, 60 divided by 35. So the diameter ratio is 1.7. We're going to square that to get the area ratio, which is 2.94. And so we're going to say that 800 divided by 2.94 gives us an answer of 272.2. Okay, did you get that?
Yeah.
Cool. Okay, this is a 3-force method question. So what you want to know is that if you have 3 forces and it tells you that they're in equilibrium, it doesn't state that it's in equilibrium, so it's a reasonable assumption. We're always allowed to assume that everything that we do is going to be in equilibrium. So what we've said here, what we're knowing here is we've got 3 forces. Those 3 forces, they're not parallel. So we can see they're clearly not parallel. So we can say that they have to be all concurrent and in equilibrium. I've already given you the answer, the angles, so we don't even need to find the point of concurrency. That's a bit of a cop-out. I was a bit too generous there. I just shouldn't have done that. I should have made you guess it. But what you can then do is just draw this up as a force polygon. And when you draw this up as a force polygon, we only know one value, which is 30. Look, I will draw it up for myself, but it's not going to be not great television, as they say. So what we've got is we've got 30 going up, and then we have 45. Oh, okay, that's a bad 30 degrees. That is, and then 45 going like that. So I'm actually drawing this as a little scale diagram, and this is one of those things that would be way better if I was in a classroom setting. Well, the answer is going to be big. Roughly, I am doing this without a ruler. I'm just getting a guess. But I'm going to say that the answers are probably going to be both about 90, more or less. I don't even think I have the answers to show people, but I can calculate it. So what I can do is I can break it up into its components. The easiest way by far is just to draw it to scale, right? Like it's just to trace those lines and just draw it to scale is the easiest way. You know, I think that when I did this, I actually did draw it up in AutoCAD, and look, it's possible that AutoCAD won't take forever. Who knows? Who knows? If AutoCAD doesn't take forever, maybe I will do it as a graphical solution. There is a way that you could, you can do it mathematically, but it's geometry, and it's going to have a couple of unknowns. The way really to solve it is to do it graphically. Control N. Okay, so we're drawing a line. Yeah, okay, a line. And we're drawing, come on, L. And then we're drawing this, what was the magnitude is 30, and it was at 60 degrees. Is that right?
Yeah.
Yeah. 30, and then the angle is 60 degrees. And then, that's pretty small, but that's okay. We can zoom in a little bit. And then we have another angle. This one here is at 45 degrees. So we can just draw that at, we'll just pick a number. We're just going to, we think it's going to be 90, so we'll go with 150 just to make it nice and long. And we're going to say at 360 minus, so it's going to be 315 degrees. And then off the other line, we're going to draw this at 27 degrees. Remember that you can just draw the lines parallel, right? So you don't need to get the protractor out. You can just draw a line that's parallel. There's an easy way to draw parallel lines. I should have shown you this in class using just a set of set squares. Okay, so again, we'll just go with a big line. We'll go with 120, looks like it's big enough. And what was the angle? 27 degrees? Mm-hmm. Okay, so 360 minus 27 is going to be 333. Yeah, you happy with that? Yeah. Okay, and then we can just trim those. That's our force polygon, and then we can take distances 96 and 93. Pretty close. 96, and it's actually 93.7, so it rounds up to 94. There you go. That was relatively okay. So C is going to be the bigger one, 96, and B is going to be 94. Okay, I really feel as though I recorded this, but it's not on my YouTube, so you know, it must be on my the school computer. Anyway, I do have AutoCAD open. I mean, I worry that it's a dangerous precedent. Yeah, I don't care enough. Yeah, sorry, it just take me too long to draw these up. If I might just draw a freehand sketch and post it as an answer. That's what I'm going to do. There we go. That's a nice compromise. Okay, that is the short version of the 2018 paper. I covered that in, I don't know, 20 minutes.